Well, so welcome again, everyone, to the Kirasato Symposium. Thank you for joining us. This is Andreu Vives, Clinical Embryology, Scientific Advisor and Medical Science Liaison of Kirasato. Today, I'm pleased to have three renowned international speakers in the IVF field. First, each of our experts will deliver their presentations. After all three presentations, we will have the Q&A session where you can ask to the speakers whatever you want. We appreciate your participation and hope you find these presentations informative and enriching. So let's start with our first speaker. He is Mr. Víctor Montalvo. Víctor holds a degree in genetics from the Autonomous University of Barcelona, achieved a master's degree in reproductive biology and assisted reproductive technology with honors from Institut Universitario de Reus, and obtained a second master's degree in biomedical research from the International University of La Rioja. Since 2018, Víctor has played a key role at the Institut Marquès, where he currently leads the embryology laboratory. His substantial engagement in the scientific community is highlighted by a noteworthy publications and a strong presence at both international and national congresses. So please, Mr. Montalvo, the floor is yours.
Thank you, Andreu, for your kind introduction. So today I'm going to speak about the importance of oil in IVF. And the first thing that came to mind when preparing this topic was this famous sentence from the Cairo Consensus that says that the only thing that is truly important in an IVF lab is everything. And I think that the closest thing to everything in the lab is oil, since it interacts with every culture media and should be present almost in every dish. And it interacts with all these variables that you can see here on the screen. Oil basically helps regulate everything. No? It acts as a barrier to contamination, it minimizes temperature changes, it maintains an optimal pH, and minimizes evaporation and osmolality changes. It even removes toxic substances from the media, and last but not least, it allows for micro-droplet culture. But all oils are not created equal. There is a lot of variables when considering oils, such as the chemical composition. No? Oils used in IVF are a complex mixture of straight-chain hydrocarbons, cyclic hydrocarbons, and unsaturated hydrocarbons, and the precise composition of those influences the chemical and physical characteristics such as viscosity or density. After the preparation, washing is generally performed by manufacturers prior to commercialization to remove trace contaminants. So I love this graph, that's why I put it here, because it illustrates the relative impact of physical stress on the embryo. No? It highlights the importance during the whole culture, but it underlines especially the first few days, where it's the most intense days for the oocytes, since now we do egg retrieval, we do denudation and ICSI, and this highlights the importance of the appropriate usage of oil during these few days. And my first idea was to quote the Cairo Consensus. The second one, obviously, was to do a bibliographical search. And now I'm going to present three papers. The first one being from Enric Mestres from Embryo Tools. In this paper, they analyzed the effect of evaporation and osmolarity in embryo culture. And they did a series of 6 experiments, but I'm going to focus on 3 ones. Before we start with the results, in mouse, it's been demonstrated that osmolarity is higher than 300 millimole kilogram in pair embryo development. So with that in mind, focusing on the top right graph, we can see that we have differences in osmolarity after the 7 days of culture, depending on the quantity of oil that we use. And in the bottom left, we can see that only incubators that use a humid environment are able to maintain this osmolarity stable throughout the 7 days of culture. And the last one I found personally interesting is that it's the design of the time-lapse dish that affects osmolarity, because not all time-lapse dishes allow for the same amount of media or the same amount of oil, and we can see that there are huge variations on them. So that's something to consider when choosing your time-lapse system. The second paper is from the same group, again, Enric Mestres in Embryo Tools, and here they did a comparison of the main competitors in the market, the main oils that we can find commercially available, and we can analyze. They analyze all these factors. Since we started with osmolarity before, we're going to continue with that, and we can see that not all oils perform the same. We can see that some of them reach toxic levels of osmolarity, and some of them they don't. And this correlates with density and with viscosity. So the more viscous or the more dense the oil is, the lower the level of osmolarity is after 7 days of culture. And focusing on another important parameter, pH, we can see that, again, not all oils behave the same. Only for some of them, after 2.5 hours, they reach an acceptable pH of 7.4, and most of them take 6 hours, sorry. And again, this correlates with viscosity and with density. And I know that all of us try to work as fast as possible when we are inside the incubator. However, it's useful to know how much time we can have working outside without altering too much the optimal conditions. And this is what we see in this graph. We can see that some oils are able to maintain pH under 7.4 for 30 minutes, while others are just not able to do so. And again, if we do the same but with temperature, we can see that for some of them it stabilizes at 36.5, for some others at 36, and that's extremely important when working in IVF. And the last parameter that got surprising results is the expanded blastocyst rate. We can see that 2 oils that are commercially available don't pass the acceptance threshold criteria, so these 2 oils would be toxic for the embryos. No? And just as sum up, I would really recommend this paper if you're interested in this topic. It's by the ESHRE, the Italian Society of Embryology. They make a great summary of everything that you can find in the literature, and that's what I'm going to sum up. I'll explain. So basically, the thickest the oil interface between medium and air, the lower the evaporation during prolonged culture, but it takes longer for the dish to equilibrate. And when speaking about density and viscosity, it's exactly the same. The higher the viscosity, the higher the density, the lower the evaporation, but it takes longer for the dish to equilibrate. And that brings us here, no? Why are we here with Kitazato, no? We are here because we are using the high pure oil since 2021, and we saw an increase in success rates, but a quick disclaimer here, it's not the only parameter that we changed since then. And so, as you saw before, no, if you wanted to prove that your product is up there with the best, you would probably go to Embryo Tools to have a comparison done by them, and that's exactly what Kitazato did. They did a comparison of the main oils in the market, and they saw that this oil maintains a stable pH for longer than most oils, and also a lower osmolarity level throughout the 7 days of culture. And as I mentioned before, no, since 2021, we did several changes in the lab. We did modifications in workflow, in equipment, and in quality control. But some of the more relevant changes were related to the usage of oil. And here I had the highlights of what we learned during the last few years. The first one being that we should use oil in every step of the treatment. I know it seems obvious, but we've seen labs that they don't use oil during denudation, during pickup, or even transfer, because they think that it's fast procedures. But if you consider that even at room temperature, differences in volume, airflow, temperature, humidity affect osmolarity if we're not using oil, imagine when we're working at 37 degrees. So oil is really important. You should use it in every dish. The second point is that more oil is better. No, increase the volume of oil using during ICSI, during biopsy, but most importantly during culture. There are some medias that they have a lower starting level of osmolarity, which might allow to use less oil because they support better a higher rise in osmolarities, but the general recommendation is use as much oil as you can. And that brings me to the third point, which is handle dishes with care, because we saw from personal experience that increasing the amount of oil used in the time-lapse dishes, it can lead to sealage and be a bit messy, in the lab. And to avoid that, what we need is just to handle in dishes with care. And the last point is quality control is essential. It's essential in every step of IVF, but most importantly in oil, because it's a petroleum-derived product and could be toxic to embryos. And unfortunately, there is not an universal standard quality for IVF. There's a lot of variation in MEA testing. There's different mouse strains, different media compositions, and duration of exposure. So you should ask your provider what type of testing are they doing. And here I wanted to show our results. In blue, you will find results from 2018 to 2021. In red, 2021 to 2024. This is patients without PGT testing, 30-year-old or younger. And you can see that on the left, we had a substantial increase in good quality blastocyst rate on day 5. And on the right, you can see higher implantations. Just to clarify again, this is not a formal study. This is just real-world data, and we have plenty of confounding factors. Causality cannot be established, but given everything that we know about pH, osmolarity, and everything that I said before, we believe that oil here plays a key role on having contributed positively in these results. And basically all of this information highlights the importance of the culture system, but most importantly of oil. Thank you so much.
Thank you very much. Thank you very much, Victor, for your nice presentation.